Hi, I'm Ollie and welcome to my presentation on the periodisation in swimming. Periodisation has been around for many years and is developed by Olympic and professional sports coaches to optimise athletic performance. Consider a competitive swimmer who excels in mid-season races but struggles to maintain peak performance for the national championships towards the end of the year. Last season, they faced burnout just weeks before the finals, undermining a year of hard work. This raises the critical question: how can periodisation prevent such timing missteps and ensure that swimmers are not only ready, but are at their best when it matters most? Periodisation is a systematic planning of athletic training. It divides a training schedule into specific progressive cycles and phases, each with distinct goals and objectives. It helps athletes improve performance, prevent overtraining, and peak at optimal times. In competitive swimming, periodisation needs to address the sport's unique physiological demands, a balance between strength, power, speed, endurance, and skill. Swimming challenges the body differently to land sports, as athletes overcome water resistance, which requires a highly efficient technique and the ability to apply force effectively in a fluid environment. The main components of a swimmer's training would include building aerobic fitness, anaerobic capacity, and muscular endurance. Periodisation allows for the development of these elements at strategic times, ensuring swimmers are conditioned to excel across their chosen race lengths, from 50-metre sprints all the way to 1500-metre events. The proper use of periodisation should make it easier for sports teams and coaches to plan and manage the training and the programming of training for individuals and teams. Core principles of periodisation. These include specificity, progression, and overload. Specificity ensures training is aligned with the swimmer's events. Drills should mimic race conditions, and they should target the muscle groups and energy systems that the athlete will be engaging during competition. Progression guides the incremental advancement in training difficulty. As the athlete's fitness or strength improves, so does the challenge of the session's exercises, pushing performance boundaries. Overload is the deliberate increase in training stress to propel physiological adaptations. By carefully upping the ante in workouts, intensity, and volume, swimmers build greater endurance and speed. In a periodized training plan, the structure is often defined by macro, meso, and micro cycles. A macro cycle is the largest unit of training planning, typically spanning an entire year, and encompasses the overall training and competition goals for the period. For example, a macro cycle may aim to peak for a major competition like a national championships. Within this cycle, the training is broken down into smaller phases, each targeting different aspects of fitness and skills. This is where a mesocycle comes in, and these are the medium-term training blocks that last several weeks up to a few months. Each mesocycle focuses on a specific component of fitness, such as building endurance, increasing speed, or tapering before a competition. For instance, an early season mesocycle might focus on building a strong aerobic base with high volume, low intensity swims, while a pre-competition mesocycle might shift towards a more race-specific training, including high-intensity work and technical refinement. Mesocycles are designed around an athlete's needs, identified through performance testing. For example, a swimmer lacking in lower body power might engage in a mesocycle focusing on strength exercises and swimming drills to enhance this area. A microcycle are the shortest cycles, generally spanning only 1 or 2 weeks, and detail the day-to-day training activities. Microcycles include specific workouts and recovery strategies. They are designed to execute the broader objectives set in the mesocycles. For example, a microcycle during a strength-building mesocycle might consist of 3 days focusing on pull strength drills, 2 days of dry land strength training, and 2 days of active recovery or technique work. Each mesocycle consists of several microcycles, which are planned with detailed attention to training demands such as session, frequency, duration, intensity, and complexity. This helps maximize performance improvements while minimizing the risk of injury and overtraining, often by varying the training intensity and volume throughout the week. When planning an athlete's yearly training, understanding the athlete's and the sport's unique requirements and physical components are crucial. A macrocycle typically spans 52 weeks and can include 1 to several cycles based on the number of events and competitions scheduled for that athlete or team. These macrocycles can be divided into 3 main periods. the preparatory phase, the competition phase, and the transition phase. The preparatory phase focuses on developing general abilities such as general strength and endurance. The competition phase adjusts the focus based on upcoming events, tailoring training to peak performance times. The transition phase follows the competition season and allows for cross-training and recovery to rejuvenate both physically and mentally. Coaches might employ varied loading structures in microcycles to optimize adaptation and recovery for their athletes. A 3-to-1 loading structure involving 3 microcycles of increasing training intensity, followed by 1 microcycle for recovery, is commonly used to build endurance and prepare for a competitive season. This method helps in managing fatigue while allowing for physiological adaptations. Alternatively, a 4-to-1 structure might be used during the early preparatory phase to enhance foundational capacities like aerobic endurance, extending the loading period to push adaptations further before entering a recovery phase. For those in heavy competition periods or with less training experience, a 2-to-1 structure offers quicker recovery intervals, balancing performance improvements with adequate rest. As competitions draw near, switching to a 2-to-1 ratio ensures that swimmers enter events with minimal fatigue, maintaining high-quality training sessions. In swimming, volume refers to the total distance swum during training, and in the initial phases of training is generally high. This helps to enhance stroke efficiency and endurance. As training progresses, volume decreases to accommodate higher intensity and prevent overtraining, particularly in long distance events like 1500 metres. Intensity, defined as the pace or effort level in swimming drills and sprints, starts low when volume is high, allowing swimmers to build that aerobic base without excessive fatigue. This intensity increases closer to competition, focusing on faster paced workouts and improved aerobic threshold. Frequency and duration of training sessions are adjusted according to the training phase. During high volume periods, sessions may occur multiple times a day to maintain overall volume, whereas in high intensity phases, frequency and duration are reduced to ensure optimal recovery and performance in each session. Physiological testing and monitoring are crucial in swimming programs, providing data about an athlete's response to training, their improvements, their strengths, and their weaknesses. Unlike other sports, swimming's unique demands make laboratory replication a bit challenging, enhancing the value of on-site physiological measurements such as heart rate and blood lactate levels during training and competitions. These tests help in assessing the effectiveness of training loads and recovery strategies. There are many tests that will be used in swimming to assess athlete development. Common ways athletes are tested to see where they stand are time trials. These are done quite often during the year and are great as they can be easily administered and replicated and can clearly show improvements. The AIS's physiological tests for elite athletes provide 3 common tests commonly conducted in swimming athletes. These include specific tests tailored to assess different aspects of an athlete's performance and conditioning. The first test is the aerobic step test, where 5 by 200 metre swims are conducted. It is designed to evaluate the aerobic endurance of sprint and middle distance swimmers. It involves swimming 200 metres intervals of increasing intensities, with measurements of heart rate, blood lactate levels, stroke rate, and stroke count taken at each stage. This test provides a detailed picture of a swimmer's endurance capabilities and muscular adaptations, making it ideal for assessing race-specific aerobic fitness. The 8 by 100 metre step test targeted at 50 metre and 100 metre sprinters. This test involves a series of 100 metre swims at escalating intensities in a maximal effort dive. It measures the swimmer's physiological responses, including heart rate and lactate levels, to varied swimming speeds. This test is crucial for evaluating a sprinter's metabolic conditioning and readiness for high-intensity competitions. The stroke mechanics test involves 6 by 50 metre swims, and this test assesses a swimmer's technical skills by monitoring changes in stroke rate and distance per stroke at increasing speeds. It is particularly useful for technical analysis and refinement, providing coaches and athletes with insights into how technique varies with intensity, which is crucial for optimizing performance in the water. In less experienced younger competitive swimmers, it's common for them to do a wider range of events, from short sprints to longer distances, as well as multiple different strokes, from freestyle to butterfly. This broad competitive scope means a periodized plan that accommodates the development of both anaerobic and aerobic capacities is important. Unlike experienced elite swimmers who often specialise in specific distances, such as sprint or long distance, younger swimmers would benefit from a more varied training regime that builds a more comprehensive foundation of skills, endurance, and speed. For younger athletes, periodisation might include longer phases that focus on building general athletic skills and basic swim techniques for longer, before advancing to more targeted training for speed and endurance. The plan would cyclically develop a wide array of physical capabilities and ensure well-rounded growth in all competitive distances. This approach not only prepares them for the demands of multiple race lengths and strokes, but also helps identify their strengths and weaknesses and preferences for future specialisations. In contrast, an elite swimmer that's been doing it for a lot longer, their periodised plan would be structured quite differently. It would be more narrowly focused, aligning with the specific metabolic and technical demands of their chosen events. For instance, a sprinter would focus more on high-intensity anaerobic workouts and speed technique, while a long-distance swimmer would concentrate on building aerobic endurance, efficiency in water, and pace control. The training cycles for these athletes would involve fewer transitions in types of physical stress, allowing for a deeper specialisation and refinement of the skills pertinent to their competitive distances. This focused approach is critical for maximising the performances where marginal gains become increasingly significant at high levels of competition. So here we can see just a very basic periodised plan for an athlete that might be doing only a couple competitions within a short period towards the end of the year. We can see they do the prep phase and the pre-competitive phase, and the strength and the swimming focuses align up with what the goal is for that phase. And then we can see that we transition into that recovery phase after the comps. Conditional aspects of training refer to the development of physical capabilities such as strength, speed, endurance, and flexibility. These are foundational to athletic performance and typically are aspects that are built progressively, often starting with a focus on general strength and muscular endurance, then progressing to more specific skills like speed, explosiveness, and power as the athlete approaches the competition season. This progression aligns with the principles of specificity and overload, where training becomes more targeted and intense over time. In swimming, conditional training is tailored to an athlete's speciality. Sprinters may prioritise explosive strength and power for short, intense bursts of speed, while distance swimmers would do more training and focus more on building a robust aerobic base for sustained performance. Mid-distance swimmers might do a balance between both of these factors. A one-size-fits-all approach is definitely not effective due to the diversity in event requirements, athlete abilities, and individual response to stimuli. For instance, a 50-metre freestyle swimmer would most likely and should have a different strength and conditioning program and swimming program compared to a 1500-metre swimmer. And same goes for a 400-metre swimmer, for example. They would be quite different in what they should be training. Psychological and technical tactical training and utilising technology. These aspects are critical components of a swimmer's overall training program. Mental conditioning, including goal setting, visualization, and coping with pressure, ideally begin in the preparatory phase to establish a strong psychological foundation. But they should ideally be built on and consistently worked throughout the whole year. It becomes particularly crucial during the pre-competition and competition phases, when the athletes must fine-tune their focus and mental resilience for peak performance. Technical skills like stroke mechanics and turns are honed throughout the training cycles, but are particularly emphasised during the early preparatory phase. This is when the volume of swimming is at its highest and the intensity is generally low. This allows for technical corrections without fatigue interfering. Advancements in technology have significantly enhanced the training landscape for swimmers. Coaches and sports scientists now have access to video-led technology, stroke analysis software, and pressure sensing systems to refine an athlete's technique. Tactical awareness, such as pacing strategies and race planning, is typically integrated during the pre-competitive and competitive phases. This is when swimmers practice implementing their technique and mental strategies in race pace or simulated competition scenarios. Athlete coaches can use a variety of tools and continuously assess progress to make necessary adjustments to a training plan. This includes physiological data like heart rate monitors and blood lactate tests, technical feedback like what I mentioned before, the video analysis, performance metrics like their time trials and simulated races to test race strategies and conditions, as well as athlete feedback, so regular check-ins on perceived exertion, fatigue levels, and overall well-being to adjust the training load and recovery strategies. Tapering is a crucial part of periodisation and athletic planning, and in swimming involves reducing training volume and maintaining intensity to optimise recovery and performance prior to a competition. This strategy has been shown to improve performance in endurance athletes by up to 2 to 22%, with longer tapers possibly enhancing psychological well-being and reducing injury. Physiological adaptations during tapering include increases in muscle fibre, diameter and power. Tapering must be done carefully though and be well thought out, as too great of a taper or reduction in training or too long of a rest period before an event can actually result in a partial detraining effect. A typical tapering approach for swimmers gradually decreases daily swim distances, for example going from 6,000 metres to 3,000 metres, while keeping high intensity efforts like 50-metre sprints or interval training reasonably constant. Strength training sessions are adjusted from high volume, so 3 sets of 12 for example, to a much lower volume, higher intense format, so 2 sets of 5 for example. This maintains muscle power without causing fatigue. By fine-tuning the balance between volume and intensity, tapering ensures swimmers are physically and mentally prepared to peak at their major competitions. Periodisation in swimming training is not a one-size-fits-all approach. It requires adaptability to meet the individual needs and responses of each and every swimmer. While the foundational concepts of periodisation, so specificity, progression, overload, provide a structured framework for developing athletic performance, the application of these principles must be dynamic. Coaches need to establish a base plan that includes microcycles, mesocycles, microcycles, designed to systematically build upon each athlete's strengths and address their weaknesses. However, for periodisation to be truly effective, it must be responsive to the athlete's ongoing development and well-being. This involves adjusting training loads and recovery periods based on the athlete's feedback, performance data, and physiological indicators throughout the season. This flexibility in planning ensures that training remains aligned with the athlete's current fitness levels and the competition demands. Ultimately, the success of a periodisation strategy hinges on the ability to be tailored and adjusted over time. This personalised approach ensures that swimmers are not only prepared to perform at their best during key competitions, but are also able to sustain high levels of performance throughout their whole career. By embracing the principles of periodisation and adapting them to each swimmer's unique circumstances, the coaches can maximise the potential of their athletes and lead to long-term success in the sport. Thanks for listening.